Quantum Tunneling COVID-19 Infection by William Johnson from Guy B. Brown School, Grade 7. Introduction. The purpose of this project is to see if SARS-CoV-2 can quantum tunnel into your skin cells and infect you with COVID-19. What is quantum tunneling? In classical physics, if an object has less energy than the barrier, it cannot go through the barrier. However, in quantum physics, if an object has less energy than the barrier, there is a probability that the object will quantum tunnel to the other side of the barrier. For something to quantum tunnel, the kinetic energy of the object needs to be less than the potential energy of the barrier, and the lower the mass of the particle, the more likely it is to quantum tunnel. How to get infected. For this, we are assuming that if a SARS-CoV-2 particle enters one of your cells, then you will be infected with COVID-19. In reality, it is more difficult because the RNA in the virus is wrapped in a spike protein which it uses to enter the cell. It loses the spike protein when it does that. If the virus quantum tunnels into the cell, it will still have the spike protein. This may make it more difficult to infect the cell. You need approximately 300 virus particles to get infected with COVID-19. For this, we will assume that one SARS-CoV-2 particle will infect you. Speed of a sneeze. The speed of a sneeze is approximately only 4.5 meters per second. However, a commonly but incorrectly used estimate is 100 meters per second. I will calculate the probability using both. The question that I wanted to address is, can SARS-CoV-2 quantum tunnel into one of your skin cells and infect you with COVID-19? My hypothesis is that SARS-CoV-2 can quantum tunnel through your skin and into one of your cells and infect you with COVID-19 because it is very small. Equation. The probability of a particle quantum tunneling through a potential energy barrier is derived from the Schrödinger equation that is listed right here, where V is the potential barrier, E is the kinetic energy possessed by the particle, A is the thickness of the barrier, M is the mass of the particle, H is Planck's constant, which is the number that is listed right here, and exp is e to the power of everything that is in the brackets in the equation. Step 1. To calculate the kinetic energy of one SARS-CoV-2 particle, first we need to know the equation for calculating kinetic energy, and that is half times the mass of the object times the velocity squared. And for one SARS-CoV-2 particle, the mass is 1 times 10 to the power of minus 18 kilograms, and the velocity is 4.5 meters per second. Therefore, the kinetic energy of one SARS-CoV-2 particle is half times 1 times 10 to the power of minus 18 times 4.5 squared, and that equals 1.0125 times 10 to the power of minus 17 joules. Step 2. The potential barrier for cells is minus 40 millivolts to minus 80 millivolts. I will select minus 40 because it will give the highest probability of quantum tunneling, because the lower the energy of the potential barrier, the greater the probability of quantum tunneling. Minus 40 millivolts equals 0.04 joules. Step 3. Skin cells, which are the barrier, are 10 nanometers thick. Step 4. The mass of one SARS-CoV-2 particle is 1 times 10 to the power of minus 18 kilograms. Step 5. Planck's constant is this number here that is very long. Step 6. exp equals e to the power of x, where x is just the entire equation that is in the brackets. Result. I solved the equation with these new numbers, and the result was that there is about a 0% chance that SARS-CoV-2 can quantum tunnel into your cells and infect you with COVID-19. If you solve the equation with the 100 meters per second value for a sneeze, it still gives a 0% chance probability. My conclusion is that my hypothesis is false. SARS-CoV-2 cannot quantum tunnel into one of your skin cells and infect you with COVID-19. Difficulties, slide 1. My first difficulty is that PowerPoint does not have a math equation editor, so I had to make the equations in Google Docs, and then I had to take screenshots of them to put them in the PowerPoint. My second difficulty was that it was very difficult to find away the potential barrier value of an object. I read many papers that I did not understand, and because this is one of the most important things in the equation, I almost decided to switch to a different project. However, I eventually found a value of the potential barrier of cells on the internet. Difficulties, slide 2. The third major difficulty I had is that it took me a long time to find an equation for quantum tunneling that was not for electrons. Another major difficulty that I had is that I had to learn the fancy scientific notation for really big or really small numbers. For example, the mass of one SARS-CoV-2 particle is 1 times 10 to the power of minus 15. That is equal to 0 point and then a lot of zeros, 1. I can see why you use the scientific notation because that takes a really long time to write. Future work, slide 1. For future work, I would like to research more about spike protein. To start with, I would like to know if a spike protein can quantum tunnel partway into a cell membrane. The spikes have a much smaller mass compared to the entire SARS-CoV-2 particle. Perhaps this is how the infection starts. Another thing I would like to know is, can the RNA quantum tunnel out of the spike protein when the virus impacts the cell? Then another thing I would like to know is, can the spike protein be unraveled while inside the cell? Because the probability of quantum tunneling is essentially 0, this does not matter, but I still find it interesting. I would also like to know if this equation of quantum tunneling can be applied to other viruses. Future work, slide 2. I would like to confirm the value of the potential barrier. Because I calculated the probability with the smallest value, this does not matter, but I still find it interesting. Another thing I would like to know is if there are any smaller viruses that can quantum tunnel into your cells and make you sick. Another thing I would like to know is there a way for SARS-CoV-2 to go faster than a sneeze? This is the end of my project. I enjoyed making it very much, but I found it very difficult. These are the sources that I used to make my project. Thank you.